Today I'm going to be working on these Nintendo Switch OLED motherboards that I've got in front of me. I have 3 here and I've got another one on the way, so 4 in total. I bought these off eBay I paid £43.99 for this one, £43.99 for this one. I've got another one on the way which I paid £35 for, and then I paid £7.50 for this one. This one I've had for a long time. I've just pulled it out of my donor box, but I haven't actually worked on it because, well, it's very, very liquid damaged, as you can probably tell. I don't know if I'm going to be able to get that one working, but that's definitely a video for another day. But in this video, I'm going to make a multi-part series on these. I'm probably going to make 4 videos in total of trying to fix these OLED boards. But basically in this video, I'm going to work on this one first. I don't know what's wrong with it. I have just put it into a housing, but I haven't actually tried to power it on or anything yet. The reason that I bought these and the reason that I paid a little bit too much for these is because I am very short on donor boards for OLEDs. In fact, the only donor board I've officially got is this one, because I did decide that I wasn't going to work on it, but now I've just changed my mind and I'm going to try and work on it anyway. So I need donor boards for Switch OLEDs. And yes, I do understand that they're pretty much the same hardware as those ones. So I've got a graveyard of normal Nintendo Switch donor boards, Nintendo Switch Lite donor boards. It's just really handy to have boards where it's the exact revision, because let's say, for example, I want to replace, I don't know, that capacitor there. I can just take, for example, a donor board, go straight to that capacitor there and know that I'm getting the right value and the right component because it's exactly the same position. So that's the reason that I wanted to buy these, but I also wanted to make some videos on actually trying to fix them, because these have been sold as scrap boards. I don't know what's wrong with them, I don't have a clue, but I thought that'd make some interesting content. So if you are new to the channel, my name is The Coder. I'm a component level technician and I teach people how to fix their own motherboards on YouTube. So if you do want to learn some more about fixing electronics, be sure to get subscribed and turn on the bell notifications, that way you don't miss any future videos. If you do want to support me in what I do, obviously these videos are completely free, but if you do want to support me in what I do have a Patreon page, so be sure to check that out. There's a link in the video description. Or if you want to support me, but you know, maybe you don't want to spend money, or you don't want to, you don't have the money to support me or something like that, but you do still want to support me in some way, just watch other videos. Or you can also go ahead and head over to Twitch, and if you've got an Amazon Prime account, you can link an Amazon Prime account to Twitch and become a Twitch Prime subscriber by linking an Amazon Prime account to Twitch and then subscribing to my Twitch channel. It only costs you a little bit of time, a couple of minutes, and as long as you've got Amazon Prime already, it's completely free. It gives me around about $2.50 every month if you renew it. By the way, I should probably mention that if anyone is a Twitch Prime subscriber, it doesn't automatically renew. So if you are a Twitch Prime subscriber, or you've been a Twitch Prime subscriber, I would appreciate it if you just check on it and just see if it's still the case where it is actually active and things, because it doesn't renew. You have to do it manually every month. So just a couple of minutes of your time every month, and it does massively support me. It helps me to buy stuff like this to be able to actually fix, to make content. So yeah, with that being said, let's get into this repair. Alright, so if I plug the battery in here and I plug in the charger, let's see what's going on with this then. So I don't know what's actually wrong with these. We get 0.3 amps of current, 15 volts, no display on the screen. So the question I'm asking there is this actually charging, or is it shorted out somewhere? You know, is there a short on the board which is drawing the 0.3 amps? And unfortunately, because there's no display on the screen, I don't actually know for sure. So what I'll do is I'm going to take this one, which I have fully charged. So I've fully charged this battery. So even though there's no display, it could still be attempting to charge a battery and turn on. It could be a display issue, you know, anything could be wrong with this. So what I'm going to do is I'm just going to jerry rig this battery onto here, because this battery here is full. I know that because I charged it last night. I did a live stream last night, and I've put a warranty sticker on this because it's for sale on my online store. So I charged this battery fully overnight. I know the battery is 100%. So if I just hook this battery up, and yes, they are exactly the same connector on the battery, pretty much the same battery, just a different revision. But if I hook that up there, I can attempt to turn it on, and I want to see if it's actually booting up. So I'm not going to attempt to turn it on with the battery or with the power button. I'm going to hook this up, because if it attempts to turn on, then my charger is going to reboot and it's just going to keep flickering when it does actually turn on. So if there's no display, no sound, whatever, it doesn't matter, because it's going to tell me whether it's going to turn on. And it looks to me like this one is not. And the CPU is a little bit warm, but not overly warm. So I don't think that's turning on at all. Alright, so the next thing I guess I'm going to try and do then is hook this up to the PC and just see if we're connected up to RCM mode, because if we're connected in RCM mode, then it's not going to attempt to boot up, it's not going to show anything. So I know this is an OLED, and you're going to think I'm a little bit strange by saying RCM mode, because these are not you know, they're not exploitable devices. But the thing that people don't realise with the Nintendo Switch is it doesn't matter what Switch you've got. It doesn't matter if it's a V1, V2, Nintendo Switch Lite or Nintendo Switch OLED. If the motherboard can't find the software, then it will put itself into recovery mode. So if you disconnect a NAND on, for example, a normal Nintendo Switch, and you hook it up to your computer, it doesn't matter what revision you've got, it will go into RCM mode. The only difference is that the exploit only works on the V1 boards, the unpatched boards. So I'm going to hook that up, and I'm going to go to my desktop here. So I'm going to load up Tegra RCM GUI. So this is actually the software which is used for exploiting Nintendo Switches. I don't use it for that, because I'm not interested in exploiting Nintendo Switches. I don't have anything to do with the exploit community. I really don't care. I use it as a diagnostic tool only. So that's what I'm going to do here. And it says no RCM device detected. So it's not actually picking up in RCM mode. So let me show you what I mean by this when I disconnect a non-exploitable board NAND and plug it into the computer. So this one. So this is a HID board. It's the final revision before the Switch Lite came out, or as the Switch Lite came out. If I disconnect the NAND, and you know this is a non-exploitable because it is a HID board, none of the HIDs are exploitable. Connect it up. And there you go. As you can see, that is in RCM mode, and that's the one that's plugged in. Obviously, there's nothing on the screen. If I do go to inject a payload, it'll just crash, because it's not an exploitable board. But if there's no NAND detected, it doesn't matter what switch it is, it will go into RCM mode. So obviously nothing on that screen now, and just to show you, this device actually does work. It's one that I fixed on a live stream last night, rather technically 2 days ago now, because it's, what, 2 AM. But if I just show you, this is working with the NAND. I'll do it exactly the same way. Connect it up to the PC. And that, there you go. And as you can see here, it's now coming up with setting up device Nintendo Switch because data's working. This one I did trace repair on the USB-C port. But as you can see by the software, which is just there, everything's opposite on this camera. Yeah, so it's not showing up as RCM mode because the NAND's been detected. So yeah, that's the way they work. A lot of people don't realise that it's a thing. But the reason I use this for diagnostics, and I know I'm rambling a little bit, but the reason I use this for diagnostics is because basically if the NAND is dead, or if there's an issue with the NAND, if there's corrosion under the NAND or whatever, then that's going to allow me to rapidly figure out the issue. And if it does go into RCM mode, then I know that I only need to focus on the power management chip and the NAND itself. So that's not going into RCM mode, so it's not a NAND issue, or it's not likely going to be a NAND issue. So it's more likely than not going to be something to do with, for example, one of the M92 or one of the power management chips like M92, P13, the Max IC, which is located just there on this one. So let's pop under the microscope and we'll see what we can do about fixing this. So I'm going to give it a visual inspection first, because like I said, I don't have a clue what's wrong with this. You'll have to excuse the auto white balance on this. The light is turned up full, but it's bouncing off this shield here, so there's not really a lot I can do about that when it's actually near a shield. The white balance is just going to automatically adjust. But I'm going to give the board a visual inspection, see what's been done to it by the last person who worked on this. This has been declared dead for a reason, remember. And there's the NAND, and as you can see, that looks absolutely fine. Okay, looking at this has been liquid damaged in the past. I'm not really overly worried about this right now. I don't think that's going to cause an issue. It's just a little bit oxidized and dull, but I don't think that's going to cause an issue. And like I said, it's not showing up in RCM mode, so it's probably fine. Let's just have a look around, see if there's anything very obvious. Okay, it appears okay so far. I'm not seeing anything. So let's just do a few checks on some components then and see what the deal is there. So I'm going to look for some shorts around mainly this M92 chip first of all, because that's normally the issue. So I've got my multimeter in continuity mode. Let's check this 0 ohm resistor first. That's good. And then I'm going to put one probe on ground and just check some of these components. They seem fine. And that's all showing up as okay. So I'm going to go into resistance mode. Let's just check the resistance on this capacitor here. And we get 4000 ohms, that's fine. So this capacitor here is linked directly to the 1.8 volt rail. And if that goes bad, a lot of the time your CPU is bad, but it can also be an issue with something like the Max ICs or the Pi 3 USB IC as well. That's why I always check that, but that seems fine. I've got my probes the wrong way there. I'm not getting a very good contact for some reason. I am getting readings in the millions of ohms, so I don't think P13 is the issue, or Pi 3. So let's have a look at the BQ24193 on this side. So this is the charging chip. This is what's responsible for charging the battery. Let's try to get that in focus. I'm going to go back to continuity mode and let's just hunt around here. Again, that seems absolutely fine. Yeah, that seems fine. Seems perfectly normal to me. I think that's normal. I think that's a low impedance line. Let's just check it on another board. Yeah, it's a low impedance line. It's like 15 ohms, which is fine. The problem is that there are a lot of low impedance lines around here. Let's just check that on this board. 53 ohms, yeah, so thereabout. Yeah, so that all appears normal. So now we need to think, what else could it possibly be? It's very unlikely going to be the audio IC, because generally we get an error code, a 2101 error code with that. If it was the LCD or anything to do with display, like backlights or anything, then chances are we will get some signs of life from it. So it's not going to be that. Could be something to do with this Max IC around here. And these all appear to be checking out. I believe that's a low impedance line, but I will double check that. Let's just double check these, because I'm not so sure about these. 37 ohms, yes, a 20 ohm difference, that's not really concerning if I'm being honest. It is low impedance, but we are going to have differences on different boards. So yeah, that's absolutely fine. So I think what I'm going to do then, the first thing I'm going to do is just change this M92 T36, because everything else appears okay, or everything that's needed for it to boot up appears fine. So I'm going to change this M92 T36. There's a good chance that could be faulty. The problem with M92 is it can show up as good and still be bad, and in fact it's fairly common. So unfortunately, doing tests for short around capacitors and stuff, it's not a definitive test. So let's just get this removed. So I've got my hot air set at 420 degrees Celsius, and that's at 40% airflow. I'll just remove that chip and add some fresh flux here. I'm gonna re-tin these because it looks like someone's already changed this chip. So I'm gonna re-tin these pads. There we go. So I'll grab a donor chip then. So that's where the donor boards come in handy because it saves you having to buy one. So like I said, this lighting, it's going to go a little bit messed up. There we go. So there's a donor chip. And there's a specific reason I've got the board in this orientation, and that's because while using a donor chip off a normal Nintendo Switch, this is the orientation it's meant to be in. Let's just let that settle for a minute, and then let's press down on the chip. I'm going to squeeze out that excess solder. So there's always going to be excess solder. If there's not, then you've probably not put enough on the ground pad. The ground pad acts as a heat sink, and we do want the chip to be able to keep itself cool. I'll just add a bit of flux there to that, and just tap on those pads to get rid of that bridge. We don't really need to do anything else to the rest of the pads. It's soldered nicely. So let's just pop in a battery. I don't need to hook it up to the screen or anything. Like I said, I can tell what's going on with it based on what happens with my charger. I'll just plug this into the charger. And of course I've plugged it in with the wrong battery. I need to plug it into the... Oh, there we go. That's booting. So what did I say about the charger resetting and flickering on and off? Let's put this in the housing, because that is turning on. I don't really need to worry about, for example, the fan and things like that. I'm not really bothered about that for now. If it charges the Joy-Con, then I know the fan circuit works as well. And I'm going to turn it on, and boom, there we go. That is working. No passcode, that's good. A lot of games on here, and it looks like they're all cloud games. Well, that's a disc. That's a kart game. Pokemon Violet. I've never played that one. I might have a go with that tonight. Okay, so 0.46, and the battery's pretty full, so yeah, that's absolutely fine. Let's just make sure it docks. Well, let's make sure it charges by flipping the charger over. Don't know if it's... I'm going to have to test fast charging independently with another battery, I think. That seems a little bit low, but for now, let's just test the docking. Let's just make sure it docks. I've got this hooked up to an official OLED dock, and yes, it does dock. So that all seems to be working. So I've got a feeling this isn't fast charging, which obviously is a problem. So I am wondering if there's still an issue with the charging circuit somewhere. Maybe P13's bad, or maybe a filter's blown. But what I'm going to do is I'm just going to disconnect this quickly, and I'm going to connect up another battery. I know this battery here does fast charge, so let's allow that to boot up. So 0.48. And there you go, that's booted. So if I disconnect that and reconnect it, there we go. Yes, it's fast charging. 0.8 amps, that's absolutely fine for the percentage that this battery's on. So that's just a battery issue on this particular battery I've got, I guess. This battery was fully charged. I guess all the reboots today that I've been doing has killed it. But never mind. So let me just hook it up to the normal battery. Ha! Hot swap. I'll probably get a 2101 error code in a second. Internet. I haven't got Wi-Fi antennas hooked up, so I probably won't be able to pick it up. I just want to make sure it doesn't throw an error code. Okay, yes, I can pick that up. So let me just log into that. Unable to connect, but yeah, that's just a signal issue. That's fine. So I'm not really bothered about signal issues. I mean, obviously I've got no antennas on this, so that's not an issue. As long as it's picking up Wi-Fi, that's all I really need to know. Let's just test Joy-Cons. I haven't got a game card module. I need to buy one, but I'm assuming it's going to work. But I will test it before I sell it. Right, that Joy-Con connects. and so does that one. Fantastic. Yeah, everything appears to be working on this. I obviously can't connect a game card module because I don't have one, but before I sell this, I've got a couple of OLED boards now. This is OLED board number 2 that I've got available for sale. So yeah, I'll sell this one first, and then this one, obviously I'm going to order a game card module because I do need to test that. This one I did test because I used the customers to test it. I know I shouldn't do it, but never mind. But yeah, there we go. That's that working. Really, really simple. It charges, it docks, it connects the Joy-Cons, Wi-Fi works. Obviously, I still need to test and make sure it's not banned, but that's not really for the video. It doesn't really matter. But then again, I can jerry-rig a Wi-Fi antenna just to connect it up. Yeah, let's connect up a PS5 Wi-Fi antenna. Why not? Just to make sure it's not banned, because that is something I do need to double check before I actually resell it. So let's jerry-rig a PS5 Wi-Fi antenna up. Right, so let's go back to internet. Full signal. There we go. Yeah, that works. Let me log into my own account. And it wants me to update. Alright, I'm going to run through this. I'll fast forward through all of this. There we go. So that's what I mean by the charger flickers when it restarts. It's perfectly normal on this charger. Link to a Nintendo account. So I'm going to log into my Nintendo account. And there we go. That appears to be absolutely fine. It seems like it's not banned. Let's go to the eShop. That appears to be fine. And the eShop, make sure that logs in. Enter the password. Okay. And yep, that seems to be absolutely fine. Nothing at all wrong with this switch. I'm happy. Obviously, the M92T36 chip is responsible for charging, and unfortunately, that wasn't showing up any kind of fault. But as I explained earlier on, it doesn't have to. It's not. Oh look, it's overheating. Lovely. It's not always an issue where it's going to show up with a short. Sometimes M92T36 can be bad, and it can show up as absolutely fine. So yeah, nice and simple. Replacing that M92T36 did the trick, and I can now, well, once I get a game card module to test this, I can give it a test and make sure it loads a game or a game cartridge, and then I can sell it on. So that's going to be for this video. Thank you very much for watching. I really do appreciate it. If you do have any comments or questions, leave them down in the comment section down below. I'll always do my best to answer. If you do want to organise a repair, check out the links in the video description. You can get in touch and send it over for repair. And of course, if you do want to support me, be sure to check out the Patreon link or the Twitch links or some of the other ways you can support me in the video description as well. So with that being said, I really appreciate the support. Thank you very much for watching. And until next time, I'll see you later. Bye for now.